Welcome to the start of Unit 9. Most students think they know what pressure is, but in AP Physics 1, pressure is where the math gets real. Today, we are laying the foundation for the entire fluid dynamic unit. We are breaking down the units you need to memorize, the definition of pressure that the college board loves to test, and the magic of Pascal's law, where a tiny push can lift a literal car. Stay with me until the end because the hydraulic lift problems we cover today are the free points of the AP exam. And hey, if you want the same deep dive but tailored to your specific pace, I am now opening spots for one-on-one coaching. Check the email in the description to join the team. Let's get to work.
All right then.
Yeah.
So this is the last unit as per the AP Physics curriculum, and I guess it's unit 8. And in this unit, we're going to talk about fluids. So what exactly we are going to cover in this unit, and what are the different principles that govern the fluids? We'll talk about that. So first of all, we all know that matter exists in 3 states, and those are solid, liquid, and gas. So liquid as well as gases, they both comprises and form fluids. Liquids and gases, they both comprises and form fluids. So this is what something you should understand. Anything which can flow, anything which has a capability to move from one place to another with a very smaller interpretation of force, you can say that thing comes under fluid, which can flow basically. That is fluid. In general, there are different type of liquids that we should deal with, but in physics, as per the requirement of AP Physics curriculum, we deal with ideal fluids only. So there is a big difference between ideal fluids and normal fluids. Ideal fluids, while understanding fluids, while dealing with all the physical concept related to fluids, we consider different properties. And these different properties make fluid, or you can say ideal fluid, different from the normal fluid which we deal with in daily life. So first of all, we need to understand that what are the characteristics of fluid. So we already know that fluids are simply that type of matter which consists of atoms and molecules which are arranged in a random manner. There is no specific pattern. Just like in solids, we do observe that atoms are arranged in a specific pattern, but in fluids, they do not arrange in that way. Similarly, fluids cannot withstand any tangential or shearing stress. So, like for example, if there is a block and the bottom of the block is fixed, and if you try to apply the force on the topmost portion, so that force is known as tangential force. So the basic property of fluid is that they do not, you can say, react to any tangential force. You cannot apply any tangential force to fluids. That is what you need to keep in mind. Similarly, fluids do not have any specific shape. They do not has any modulus of rigidity also. Basically, there is no rigidity thing that comes in fluid, or you can say we use that word in fluids. Apart from this, fluids do not have any capability of applying forces, but they have capability of applying pressure. So that is a different thing which we will try to understand and see that how we can calculate them. So what makes a fluid different from ideal fluid? That is what we need to understand. First of all, in case of ideal fluid, what we see is that flow of liquid molecules, or you can say even gaseous molecules, it is streamline. Now, what is streamline? Streamline means, suppose this is a flow. So every particle in a fluid follows the exact same path as the preceding particle. So for example, if this is my first particle and this is my second particle, so second particle will 100% follow the path followed by the first particle. That what makes the flow streamline, and that is what which is shown by ideal fluid. Similarly, there are different things. So they are ideal. So they have a specific density. So we do use density or defined density of fluid, just like normal fluid, which is mass of liquid over volume of the container in which it is kept, or in the volume of the liquid. Similarly, there are some basic properties. Ideal fluids are incompressible. Like generally, what we observe is that when we are talking about fluids, they do have some space between them, and that space generally carries oxygen, which is equally responsible for aquatic life to sustain. But ideal fluid, or the fluid which we are going to deal with here in physics, is incompressible. There is no space. There is no space between the liquid molecules. So that is completely called ideal fluid. Similarly, ideal fluid is non-viscous. Now, what is viscous? Viscous means you can say that the thickness, or you can say that the flow is comparing to any liquid which is quite thick in nature, is not something which is viscous. Like for example, if I take two different type of liquids, let's say one is milk and another is honey. So in case of honey, we will observe that it is more thick in nature, or the particles are more bounded to each other. So that makes honey more viscous. Whereas if we talk about milk, milk is less viscous. So ideal fluids are those fluids which are 100% non-viscous fluid. Then we have another property, or you can say another characteristic of ideal fluid, which is called irrotational. Irrotational flow. Now, what does it mean? It simply means, just try to understand it this way. Suppose there are fluid particles which are flowing like that. So what we observe is that some water droplets do reach the different, or you can say, against the line of motion of different particles. And why such thing happens? That such thing happens because of air inside the liquid. Like for example, if you just turn on a tap, if you just turn on a tap, what you will observe is that this tap is releasing water upon your rotation, but what you will observe, this particular space and this particular space do has liquid molecules on it. What does it shows? It shows that the liquid, general liquid, or you can say the liquid which we deal with in daily life, has some rotational properties. Like for example, you must have seen that when river flows through different points, it ultimately forms some currents which is circular in nature, and that circular current is only because of this rotational behavior of fluid. But the fluid with which we are going to deal with, that is ideal fluid, is going to be irrotational in nature. Like the molecules will travel only in a straight line, which forms streamline or laminar flow. We can also call it as laminar flow. So this is kind of very important to understand that what these properties are. And when we are dealing with such fluid or such phenomena, we have to consider that these properties are there with fluids. There is no such things that exist with the questions we are dealing with in comparison to what we observe in real life. That is completely different scenario. Now, this particular unit comes under fluid mechanics. Fluid mechanics deals with two specific sections, or you can say subsections. The first is static fluid, and the another is fluid dynamics. Do you know what is the difference between static fluid and fluid dynamics?
One is moving and one isn't.
Yes, one is at rest. So what we're going to do here is we're going to learn the different properties of fluid based upon these two categories. Either fluid is at rest, either fluid is in motion. So whenever we observe that fluid is at rest, that study of fluid comes under static fluid. Now, what are the different properties we're going to learn here in static fluid? The very first thing, if fluid is at rest, the basic thing we are going to observe is the pressure. As you know that as much as we go deep into the ocean, the pressure increases. Why pressure increases, we'll talk about that also. Similarly, we'll talk about viscosity. Viscosity is another property which is because of static fluid. Apart from this, we'll also talk about surface tension. Surface tension is another such property which is due to static nature of fluid. Although these things do exist in dynamic fluid, but if we talk about the simplicity of the questions, that thing will come under static fluid only. Similarly, if we talk about dynamic fluid, fluid dynamics, it means fluid is in motion. So whenever fluid is in motion, again, there are different scenarios, or you can say different phenomena that we have to deal with. The first thing we're going to deal here is rate flow, like how fast or how slow a liquid flows. Similarly, we will also try to understand what is equation of continuity, because equation of continuity give us the idea of flow rate or rate flow of liquid. Like, for example, if there are two taps, one tap has the capability to, you can say, exert water with greater force, whereas another tap has some sort of lower capability to do that. So the flow rate is again going to be different for both the cases. Similarly, the capability of releasing water in a given time is also going to be different in two different taps. So we'll try to understand what exactly it is. And last but not the least, we're talking about Bernoulli's principle here. Whenever we are talking about Bernoulli's principle, we will simply try to understand that energy conservation principle also exists for flowing liquid. Like whatever we have learned so far in physics, we just keep this thing in mind that energy is conserved. So this energy conservation is not only which is limited to solids, or not something which is limited to first few chapters we learned in physics, but it is something which is consistent throughout the universe. For each and every type of matter, energy is conserved. We'll try to understand what Bernoulli's principle says. Apart from this, there are a few other things as well. Like, for example, we'll talk about Archimedes' principle. Archimedes' principle give us the idea about law of flotation. Why some objects sink in the water, and whereas why some object floats on water. So what are the different criteria? We'll talk about that only. So in today's class, we are going to deal with static fluid, and we're going to understand that what are the different phenomena related with static fluid. We'll start with few important properties and as well as few important definitions. Then we'll move towards the numerical section, or you can say the problem section as well. The first thing we define here is thrust, or you can say thrust of a liquid. So this is quite similar to what pressure is, but it has a different meaning. Somewhat it has a different meaning. So we will simply say the total force which is exerted by a liquid on any surface. The total force exerted by a liquid on any surface in contact with it is called thrust. So what does it mean? For example, suppose you have a huge pipe, and this pipe releases water, and what we are doing is using that pipe, we are throwing or pointing out that water onto a wall. So the thrust which this wall is supposed to feel or supposed to face, that thrust is nothing but force over area. Whatever force that liquid cannon is capable of exerting on the wall per unit area onto which the liquid is hitting, that is something we call thrust. So we do observe different phenomena where we are supposed to calculate thrust. So that is something we need to understand. Similarly, We also talk about pressure here. So pressure and thrust, they are kind of similar things, but they do have a different meaning. Whenever we are talking about thrust, we are talking about that it is something which acts on a huge surface, because in order thrust to act, we need a surface, a huge surface. Whereas if we're talking about pressure, so pressure is again force per unit area, or I can also say it as thrust per unit area. So this force and this term thrust, this explains that how much opposing force or how much resistance a particular unit area is experiencing. So whenever examiner asks you to calculate pressure, we will be looking at what force is given. Or sometimes it also mentioned that the thrust acting on the surface is this. So force per unit area or thrust per unit area is something we call pressure. Now it might be confusing that we have written thrust is also force per unit area and pressure is also force per unit area. So thrust is something which we calculate for like very small area, very small area. For example, suppose you are hitting an iron nail using hammer onto a wall. So that area which you are dealing with, you will say that that area is experiencing some thrust. Whereas in case of pressure, the area is somewhat bigger. Similarly, if you try to understand that what is the unit of calculating pressure, we'll simply call Pascal or Newton per meter square. Now, the most important part here is that this pressure has a lot of units. It is not something which is limited to pascals or you can say Newton per meter square, but there are few different units as well which are being used in a question asked by the examiner. So let's talk about those units. This is the important part. Units for pressure. The first is Pascal or Newton per meter square. What is this? This is SI unit. In most of the cases, you'll be using that unit only. But apart from this, if we talk about another unit, it's called dyne per centimeter square. This is CGS unit. You might see some questions in which pressure is given in that unit. Similarly, we have another unit called atmosphere. Atmosphere is also represented by ATM. Atmosphere is something which is the pressure exerted by atmosphere on us. So one ATM has a very specific value which is 1.013 times 10 to the power 5 pascals. Are you getting it? This is
Uh,
the value of pressure that we suffers every moment.
oh yeah,
Like,
teacher told us about this one. Yeah, yeah.
so if you just try to understand this to a greater extent, whenever a space, whenever an astronaut went onto space, they wear a special suit. That suit is not something which is weird for somebody. Well, that suit has a very lot of purpose to wear, but the most important purpose of that suit is to provide a body 1 atm of pressure, because we humans living on Earth are born with actually we born with dealing with that pressure. So once we went out of the Earth and the pressure is not anymore there, so there is a possibility that the blood in our veins might collapse, or we might feel we might suffer different hemorrhages. So in order to avoid that, the first and the most important reason to wear those space suit is to suffer that atmosphere. That is called 1/8 length. Similarly, in different industries, or you can say in meteorology to be precise, where we deal with atmospheric pressure, we measure pressure in bars, and 1 bar is equals to 10 to the power 5 Pascal, and this thing is equals to 10 to the power 6 dyne per centimeter square. Again, pressure is the only physical quantity you're dealing in physics which has a lot of units. Another unit we do use is millibars, which is 10 to the power minus 3 Pascal, or you can say which is 10 to the power minus 3 bar, which is equals to 100 pascals. Then we have another unit which is known as torr. It is used to, or you can say it is somewhat equals to 1 mm of Hg, that is 1 mm of mercury. You must have used this unit in lab if you remember.
Which unit, sir?
Mm of Hg, that is mm of mercury.
No, we never use that.
Did you ever use those old um, thermometers in
No,
which
no,
mercury
I've never used that
rises?
one. No, no,
Have you
no.
seen those
Yeah, yeah. I think
thermometers?
my dad had one, I think.
Okay.
It's very dangerous though.
Yeah, it is. But in earlier days, we have only that thing
It's
because they also have a lot of, you can say,
very,
application.
it's very accurate, no?
Yeah, we can say that, but the thermometers we are using right now, they are platinum resistant thermometers and they are also very accurate. There is
Oh,
no problem with the accuracy. So yeah.
okay.
What is the practical application of pressure if you just try to understand it? So basically, you just need to understand that a sharp knife cuts better than a blunt knife. That is only because of the pressure it is capable of exerting. Similarly, the railway tracks are laid on a wooden sleepers. Why they are laid on a wooden sleeper? So that they absorb more pressure. Otherwise, it is difficult for the train to cross over it. Similarly, it is very difficult for us to walk on sand while camel can walk very easily on sand because of the flat feet they have. Similarly, pins and nails are made to be pointed so that they can exert more pressure upon small application of force. Let me give you a very simple, a very basic question. Just try to answer it. So the question says, how much pressure will a man of weight 80 kg exert on ground when? First part, he is lying. Second, when he is standing. What is given to us is area of body is 0.6 meter square, and that of foot is also given, which is 80 centimeters square. So you have to find out that how much pressure is being exerted in these two cases.
Oh,
Think about it and tell me how we're supposed to do this.
so for the first part, it will be um 800 over the area of the body, which is 0.6. And then for the second one, it will be 800 over 0.16 centimeters.
0.16. No.
Meter 160. Oh, 1.6. Sorry, 1.6. 1.6. 800 over 1.6 meter.
No, no, no. Okay, let's try to understand it. So in the first case, or whether it is in the second case, we have to find pressure, and pressure is nothing but force per unit area. As we know that force is nothing but mg because the mass of the body is 80 kgs. But what about area? Area will be different in both the cases. Whenever you are dealing with such problems, you have to make sure that you use SI units. So in the first case, it is going to be 800 over 0.6. So once you solve this, we'll have around 4000 over 3, and we can write it as Newton per meter square. You can solve it, but yeah, that's enough.
Wait, so
Similarly,
isn't it 800, not 8,000?
yeah, but you have to divide it by area of body, which is 0.6. So once you solve this, it will be 4000 over 3.
Oh, okay.
Yeah. Similarly, in the second case, the area of foot is given as 80 centimeters. So how are you supposed to write 80 centimeters in meter
You
square?
divide it by 100, but then you have to add two, right? You have to add one more because he has 2 feet.
Mm, no. See, first of all, you have to convert 80 centimeters square into meter square. So we are not supposed to divide it by 100.
Oh, yes. Sorry. You have to divide it by like 100 squared, no?
Yeah. So we
Okay.
can simply write it as 80 times 10 to the power minus 4. Now it becomes meter square.
Times 2.
Yeah. And when it is standing, we have to multiply it by 2. So 80 times this. So we are left with 10 here. We'll solve this. It is going to be 5. So 5 times 10 to the power 4 Newton per meter square. Now just think about it and tell me in which case pressure exert on the ground will be more.
When you're standing up, because the area is
Exactly.
much less.
Exactly. So this is how you're going to deal with pressure related problems. One more question for you. Question says that the atmospheric pressure which is given to us is approximately 100 kilopascals. So this is what atmospheric pressure is given to us. Question is how large force does the air in a room exert on the inside of the window, that is 40 centimeter times 80 centimeters. Find force that is exerted on 40 centimeter times 80 centimeter window.
Okay, so then it's just one. So kilopascal is like 1,000,
Yeah, so it will become 10 to the power 5 pascals.
Yeah, 10 to the power of 5 times 0.04. Sorry, no, just 0. It's 0.4 times 0.8.
First of all, try to write the area in centimeter square and then you need to convert it into
Oh,
meter square.
okay. Yeah, sorry.
So it is going to
It's
become
10 to the 5 times 3,200 divided by 1,000. Yeah.
yeah. So we have to find force. So force is nothing but pressure times area.
Yes.
So we'll simply multiply
Yes.
0.32 times 10 to the power 5, and this will give us the result in newtons. So this is how you're supposed to find out force in different scenarios. Clear?
Yes, sir.
Now let's talk about density. What is density? So density is another physical property by which we can actually measure how dense a substance is. So finding out density of any material given to us or any fluid given to us, we'll simply say that density is nothing but mass per unit volume. Its unit is going to be kilogram per meter cube, because the unit of volume is meter cube. Similarly, we do see that it has a unit gram per centimeter cube. And the most important part here is density of water. This is something you need to remember. So density of water is 1000 kilogram per meter cube. Also, if we write it in different unit, it is going to be 1 gram per centimeter cube. So
A
these
very
two
nice
values
number.
sometimes, yeah, these two values are sometimes given in the question, but sometimes they are not going to be there in the question. So we have to remember this. At least for water, we should remember it. In SI
Okay.
units, it is going to be 1000, and in some other unit, that is gram per centimeter cube, it is going to be 1. Similarly, another important term here, which we are going to use, or this examiner going to use a lot, is called specific gravity. Specific
Oh yeah.
gravity is also known as relative density. So whenever you see these two terms, specific or relative, this these two terms simply means one thing, that we are going to
The-
compare,
It's a
that we are going
ratio.
to, yeah, we are going to compare the density of a given object with the density of water at 4 degrees Celsius. So it gives us the comparison, or it gives us the ratio. So we'll simply say the ratio of the density of the substance to the density of water at 4 degrees Celsius. Now this is very important, this temperature. We take density of water at 4 degrees Celsius because density of water at 4 degrees Celsius is the maximum density. And this is that maximum density, that is 1000 kilogram per meter cube. So
Okay.
that is something you have to keep in mind.
I always wondered why it was
So
4 degrees.
because at 4 degrees Celsius, density of water is maximum.
Okay.
And again, it is very interesting to understand this fact that nature has created water such a unique matter that if the density is not maximum at 4 degrees Celsius, we won't be able to see any aquatic life. All form of aquatic life lies because of density of water is maximum at 4 degrees Celsius. Like it is the most, you can say, wonderful thing that we humans ever came across. Because
Wi-
generally density decreases with increase in temperature. But in case of water, when we go from 0 to 4 degrees Celsius, density increases. So that's what make it more precious, or you can say an amazing matter to study.
It's
Water is somewhat, yeah.
but like isn't the water like in oceans not 4 degrees though? So like how would that impact aquatic life?
No, 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 it's not like that. It's simply like that. Whenever we are talking about aquatic life in Atlantic regions or in polar regions, there is an aquatic life. There exists an aquatic life in colder regions like Alaska and some part of those, some part of Earth, some that part of Earth. What we observe
Yes.
is that in winters, lakes went completely frozen, and that complete frozen lakes still has aquatic life in it, and that is because of this nature of 4 degrees Celsius. It is not there in your curriculum, otherwise I would definitely let you understand that what that behavior of water is and how it is how it is important for aquatic life to exist. But as of now, I will suggest you to keep this thing in mind, that 4 degrees Celsius is the reason why there is an aquatic life in some in winters also. In winters as well as in colder regions where there is a huge, I can say, like temperature drops to negative 15, 20. Still, there is an aquatic life because of this particular thing.
Okay.
This is something also known as anomalous behavior of water. That density thing is also known as anomalous behavior of water. Because if it is not there, a lot of things will not be there. Similarly, if we talk about Pascal's law, that is another question, another topic. Again, whatever we are doing right now, we are dealing with static fluid only. Fluid is not in motion yet. Fluid is completely abstract, completely at rest till now. So let's talk about what is Pascal's law. So again, Pascal was one of the most brilliant mind of that era. He observed one thing. Just try to understand it. He observed that one thing, if we have water in different size containers, if we have water in different sized containers, let's say till here, and these two containers, these two openings has different area. Let me consider that area of this particular space is smaller and area of this particular space is capital A. So what Pascal observed is, he simply said that irrespective of the area, pressure exerted on a liquid will be equally transmitted in all the directions to the same height. What does it mean? It simply means that if I choose 2 points, one is here A, another is here B. So he simply told that pressure at A must be equals to pressure at point B.
Oh,
This
because
is
the
what
number of
Pascal's law
particles.
is.
Oh, because the number of particles above you are the same if the depth of the height of the water at the
Yeah.
points are the
What
same.
Yeah, the depth, what is required is depth should be same.
Oh, okay,
So
okay.
pressure at point A must be equals to pressure at point B. This Pascal's law has lot of applications. Like in the earlier, or you can say in 20th century, earlier 20th century, when we were dealing with automobiles, which just came into the existence, Pascal's law was the reason we have different things with us. For example, we got hydraulic lift that is completely based upon Pascal's law. We have hydraulic brakes, which we used in the earlier 20th century, that was also based upon hydraulic brakes. So these two applications of Pascal's law actually help us to develop more in automobile industry. Before that, there was no such thing. We were simply using carts pulled by animals. So that was a different scenario. This was the fundamental, we can say, the leading. I can say that was the time when world actually start advancing in automobile industries. So again, the most important part is pressure at point A must be equals to pressure at point B if both the points are at same depth. Again, I'm talking about depth, not height. Because as soon as we are going to measure the length, we measure length from the surface of water, not the bottom of the container. That is why it is depth. So let's do a question. This will teach you a lot of things. Try to understand what question says. So there's a question. It says that there are two pistons of hydraulic press have diameters 30 centimeter and 2.5 centimeter. What is force exerted by larger piston when 50 kg is placed on the smaller piston. Did you get the question?
Um,
Let
is
me
that
let me give you a little bit more idea about it.
ridiculous? It's
So,
placed on this one. What is the force exerted by the longer piston when 50 kilos is placed on the smaller piston?
so first of all, this is hydraulic press, and initially how it's supposed to work is that there's a liquid filled in a container connected through a long chamber which consists of water, obviously. So there is a piston.
Oh,
This is something we call piston. Now, what happens here is that both the pistons has different diameters. So the bigger piston has diameter of 30 centimeters. The smaller piston has the diameter of 2.5 centimeters. What we did is that we placed a 50 kg mass over here. So when we place a 50 kg mass over here, what we will observe? We will observe that it will exert force in the downward direction. If this piston exert a force in the downward direction, ultimately this force will travel through the water and it will exert force on the larger or bigger piston in the upward direction like that. So I can mark this as F1, and in as a
yes.
result we are going to have F2 here. Again,
Oh, okay, okay. I see,
yeah,
sir. I see.
whenever we are
Okay.
solving such problems, we have to keep this thing in mind that the depth of both the pistons is same.
Oh, the depth is the
That
same. That means the pressure will also be the same.
exactly. So we choose 2 points here. Once one we make point one, we assume that point two. So
Okay.
pressure at point one must be equals to pressure at point two. This is what which is suggested by Pascal's law. So pressure at point one can be written as F2 by A2, and it can be written as F1 by A1. What we have to find is we have to find F2, that how much force exerted by the larger piston. Before that, just tell me what is the force exerted by the smaller piston.
So the force, it's 500 newtons.
Correct. So if you try to find out F2, it is going to be F1 times A2 over A1. What is F1? It is going to be 500. What is A1? Again, as it is a piston, so pistons are generally cylindrical, and cylindrical pistons has area that is circular. So it is going to be pi r2 square over pi r1 square. Pi will cancel out pi. Area of circle is nothing but pi r square. What about r2? R2 is the diameter. Sorry, radius. So diameter will be diameter is 30 centimeters. So radius is going to be 15 centimeters, right?
Yes.
Similarly, for the first case, it is going to be 2.5. So that radius is going to be 1.25. So 1.25 times 1.25. You simply have to solve this and you will have the force exerted on the second piston due to the first one, which is of where we kept 50 kgs of mass. Solve it and tell me what should be the exact answer.
Okay, sir. So 515 times 15. 100 times 100. 25 times 15. 375. 375 into 500 times 500. Then we divide that by 1.25 times 1.25. Divide by 1.25. 72,000.
72,000.
Yeah.
All right. So, what we understand from this particular result, even by small force of 500 newtons only, this hydraulic press has capability to multiply it and give us a very huge result. Like this is the output, whereas this is the input. 500 newtons is the input, and whereas 72,000 is the output. So this hydraulic press or hydraulic lift is also known as force multiplier because it has this capability to multiply force to a greater extent. That is what you need to keep in your mind. Is it clear?
Yes. Wait. Oh, yes, that's clear. I think so.
I'll share some questions based upon these things only. Just go through with those questions, and we'll discuss. There are so many other things as well in this chapter. We'll discuss each and everything one by one. Again, whenever we are,
Could you repeat the last part, sir? What you said before that? I didn't hear that clearly.
I said that this hydraulic press or hydraulic lift is something which is also known as force multiplier. Because here, what you will observe is here you will observe that a small amount of force which you are applying can give you a greater multiplied force, as you can see in the example also. A
Small
small
multi.
500 newtons of force gave you
Yes.
72,000 newtons of force, which is huge, which is
Oh,
a lot more
oh
than what
wow.
you have applied. So this is how hydraulic lift work. This is how we do use to lift the car or to change the stepney of a car, basically. So that is something has a lot of application. Although in today's world we have replaced it, with some mechanical lifters, which doesn't involve any use of liquid in it. Although the earlier times we do use hydraulic lift, which has liquid in it, which help us to transmit pressure quite well to the other end. But
Wait,
nowadays we do have different machines
sir.
to deal with. Yeah.
If we exert 500 newtons of force and then out we get 72,000 newtons, then doesn't that mean energy is not conserved? Because
No,
like if we
obviously not.
multiply the force by the distance, and we know that
What
work is
distance?
delta k,
What
like
distance?
the distance we push it down by,
No. It's not like that.
then how
Here,
do we how does this hold?
here, what we are dealing with is liquid. We are dealing with fluid. Now, as we know that we were dealing with ideal fluids and there is no space between the particles of ideal fluid. So, what liquid does is, if they experience a small force, they have capability of to transmit it onto the another direction. Like for example, if there is a pipe and this pipe is closed from both the ends, we just open it from this end and exert pressure. So because of that pressure, this other end might be possible that it get open. It might be possible that water start leaking from that point because of the pressure. So
Oh,
pressure is a different thing. Pressure is a whole lot different thing. There is one case you might have heard in 2024, I guess, where this Boeing submarine
oh, the one with the PS3 controller. That's how they controlled it underwater.
that
Yeah,
imploded
the ocean gate.
while while going into the while going to explore the Titanic debris. So you cannot imagine what pressure is and what it can do to anything it came across. We'll talk about it. We'll discuss. There are a
Okay,
lot of things that we need to work on. We need to discuss upon.
okay, sir.
As of now, let's keep it till here only.